Hi, and welcome to question 11 of the 2024 Junior Cert Higher Level Maths paper. So question 11 is basically around like algebra, kind of arithmetic algebra. So part A here says work out the value of 12 minus 3k to be squared. Now, that's not an equation. There's no equal sign. But they do then say when k is equal to minus 2. So the trick here is to go, well, look, this is not an equation. I can't solve it. But they do give me more information, so I can evaluate it. And I can evaluate it by just simply, in brackets, replacing the k by the -2 because these are the same thing. So if these are the same thing, why aren't these the same thing? The -2 is k, so you can swap it out. Now you can throw that in the calculator. You should always put the negative number in brackets because -2 all to be squared is going to become +4. Then there's 12. Do multiplication first, -12, and I get an answer of 0. That's it. So nice and handy, okay, in a way, as long as you don't get overly confused by the lingo. Now, that's the answer. Now, they're going to test different methods of factorization. So in this case, they're saying factorize fully pm plus 3p minus m minus 3. So this is not an equation, it's just an expression, and they're just asking you to show that you can do this particular skill. So it's most likely going to be assessed. It's only awkward when we have to move the variables around, but the general way it's done is split it down the middle, and we're looking for something common to both of these terms. Now I can see p is common. So if I pull p out, or what would this be if I divided both PM and 3P by P, or how else could I express it? So if I pull P out, I'd be left with P times M plus 3. Okay. In a sense, what have I done? Well, I've divided 3M plus 3P. I divided both by P. Okay. And that's, gives me M plus P. But I did that in order to do a trick because at all stages there, everything was still multiplied by P. Okay. Actually, sorry, 3. So basically, the way we say it is pulling P out, but in essence, both terms are being divided by what's being pulled out and what you left when you do that division. So PM divided by P would be M, but we're still multiplying that by P. 3 P divided by P would be left with 3. Now, whatever we get here, we should get mirrored on the far side. Okay. Now then you kind of look at what would I need to pull out, or what would I need to divide these by to get m plus 3. Now, if you see it, it'd be -1. So my factors are p minus 1 times m plus 3. Now, if you wanted to see where you write, okay, if you multiply those brackets together, you should end up with the original statement. So let's test it. P by m is pm. P by 3 is 3p. -1 by m is -1m. And -1 by 3 is -3. Now we don't need the -1 there, so that pm plus 3p minus m minus 3 is what we start with. So factorization effectively just changes the look of something. So you're just proving that you can do this skill. And once you get the hang of it, it's pretty straightforward. It's predictable as long as you don't have to reorder these to get something that matches. That's the kind of more complex version of that particular question. Okay. So that's part B, and then the answer. Now, part C here is looking at number systems, and it says graph each of the following inequalities on the number line given. Now, an inequality is kind of like an equation, but it's just giving a more broad definition of what's happening. So the inequality here is x is less than 2, and it says where x is an element of z. So that's an integer. Okay, Z stands for Zalan number, which means integer, which are the positive or negative whole numbers. Okay, so if x is less than 2, it's not equal to 2. So it's the next lower whole number. So it's 2. Okay, now every whole number lower than that would be 0, -1, -2, -3, -4, on to infinity. Okay, you don't fill in the gaps between the dots because an integer is not like 1.5. That's not an integer. Now the next one there is x is less than or equal to 3, so that's over here. Okay, I'll just mark it for a second, where x is an element of n. Now that means that it's a natural number. Now natural numbers are the positive whole numbers, not including 0, sometimes called the counting numbers. So all the numbers less than 3, but it can be equal to 3. So we'll fill that in there. We'll fill in the next one down, 2, 1. Now we don't fill in 0 because 0 is not natural. We don't fill in the negatives because they're not natural. And anything in between is not a whole number. So that's the answer for that one. Now there's a range here for the last part. -2 is less than x, which is less than or equal to 4, where x is an element of r, which means it's a real number, which effectively means it can be any number. So positive, negative, fraction, decimal, whatever. So where -2 is here, now it's saying x is not -2, it's not equal to it. So I'm going to fill it in there with a circle, not fill in the circle. And then it ranges up as far as +4, okay? But it can be equal to +4, so I will fill that in, and it can be every number, so a heavy line to represent all the numbers between -2, but not including -2, up as far as 4, but including 4. Now that should be the answer there. Okay, now I probably shouldn't have bothered illustrating the 2 up here. I didn't need to bother putting anything, but that's just for illustration. Now the last part D here says, write the following expression as a single fraction in its simplest form. Now question D can be very tricky, so let's read through. Write the following expression as a single fraction in its simplest form. And they give basically 2 algebraic fractions and they're being added together. So sometimes what I like to do here is just like kind of approach this as if it was just a normal fraction, just to get my head around what I'm going to have to do. And usually you find a common denominator. Now it doesn't always have to be the lowest. The easiest common denominator to get is to multiply the 2 numbers by each other, the 2 denominators, 2 by 3. And then you're basically converting both into the same type of fraction, and then they can be added together. So whatever denominator here on the 2, you kind of cancels out the 1 below, and you multiply the top, so 3 by 1. Okay, plus we move over, that whatever is the denominator here kind of cancels out the 1 below, and you multiply the other number by the numerator. Then you end up with 3 plus 2. 3 by 1 is 3, 2 by 1 is 2, over 6. 3 and 2 is 5 over 6. Now we're going to mimic that, okay, in terms of this. So our denominator here, sorry about that, clear off the writing, would be, in this situation, would be 3 times 5x plus 2. So I'm going to use brackets to represent multiplication. And then we do the same thing. Whatever the denominator is here, okay, cancels out on the bottom, and we multiply by the other of the common denominator. So in this case, the 5x plus 2. And we multiply that by the top, which is the 5x minus 2. Now we're adding that to, we move over. The 5x plus 2 cancels out that of the part of the common denominator, and we multiply by the other part, 3, by what's on top here, which is 2. Now we've created a little bit of a problem for ourselves in that 5x plus 2 multiplied by 5x minus 2 is a specific method. Now the way I would always do it is, or suggest to do it, is to write one of the brackets out twice. So I'm going to do the 5x minus 2 by 5x minus 2. And then the first term here gets multiplied in. Now excuse me, I'm going off the screen. And the second number here multiplies into the second bracket. So if we move across, 5x by 5x is 25x squared. 5x times minus 2 is minus 10x. Plus 2 by 5x is plus 10x. and then 2 by minus 2 is minus 4. Now, if you combine the terms there, you'll see that the minus 10x and the plus 10x will cancel each other out, and we're left with 25x squared minus 4. Now, that is the same thing as this. So I can replace them. So 25x squared minus 4. Now, on the far side, I'm back to the main part. 3 by 2 is 6. All divided by, I could multiply this out. That would be 15x plus 6. Now I can combine these two terms together, 25x squared plus 2 over 15x plus 6. Now, as far as I can tell, there's no way to simplify that any further. I was looking for a second, would I factorize this? But no, it's not factorized. Sorry, no, this is the simplest form. So the answer I came up with on the working notes here, and we'll go through it again. So we had our fraction. Now there are two different types of fraction, but if we can change them into the same type, we can add them together. We found a common denominator by multiplying these two denominators, okay, and I represented that here. And then we followed through on the methodology that the denominator here cancels out the common denominator, and you multiply by the other denominator. Then we had a problem there, multiplying that by 5x minus 2, which we dealt with. Then we had the second fraction, the 5x plus 2, okay, divides in and cancels out the other denominator, leaving the 3, which multiplies by the numerator, which was the 2. Now we had all these other problems then. Okay. We dealt with the 5x plus 2 times 5x minus 2, and we got 25x squared minus 4. The 3 times 2 was 6. Then we combined them together. Minus 4 plus 6 gave me the plus 2. Couldn't simplify it any further and just presented my answer. Okay. I don't know why that's I don't see much of a difference leaving it either way, either form. So that should be the end of question 11. Okay, as always, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 12.